Assalamualaikum and hi, welcome to my group presentation. As you can see on the screen, our topic that we will be presenting is about titration in food industry for soft drink. Our group consists of 5 members, which are Nur Fariza binti Jumat, Nurini Akila binti Mokhtar, Nur Faraziha binti Razi, Shaza Shamimi binti Azrul Nizam, and lastly, me, Nur Adina Husna binti Jamil. We are from F4S1204_3. First of all, I'd like to give you an overview about titration. Titration is the slow addition of one solution with a known concentration called a titrant to a known volume of another solution with an unknown concentration until the reaction is neutralized, which is usually indicated by a color change. Acid-based titration is a common technique used in food analysis to determine the titratable acidity of juice, wines, and other food products, which is a measure of the total concentration of organic acid present by Susan Nielsen 2010. Titration is an analytical technique that is widely used in food industry. It allows food manufacturers to determine the quantity of a reactant in a sample. In this experiment, the amount of citric acid in the soft drink Sprite will be measured by titration. The carbonic acid in the soft drink was eliminated by letting it to flatten before titration. Thus, it is no longer a factor to consider. The quantity of acid or base in a solution may be seen visually with the use of indicators. For this experiment, an indicator known as phenolphthalein will be used.
And I will explain about the theory of titration in food industry. Titration is an analytical technique used to determine the concentration of a solid in solution by reacting it with standard solution of non-concentration. The equivalent point is reached when the amount of titrant added is stoichiometrically equivalent to the quantity of analyte in the sample, ensuring that the chemical reaction between them is complete. The end point is the stage in the titration process where a noticeable change happens, such as color changes due to an indicator or a pH change, signaling that the equivalent point has been reached. Purpose of titration. The purpose of titration is to determine the concentration of specific substance in the solution by reacting it with a reagent of non-concentration. This analytical technique is used to precisely quantify the amount of an analyte, ensuring accuracy in various chemical processes. Titration is essential in fields such as pharmaceuticals, environmental monitoring, and food chemistry, where precise measurements are crucial for quality control, regulatory compliance, and safety assessments. Next is the types of titration. There are 4 types of titration in food industry. The first type of titration is acid-based titration. It used to measure the acidity or alkalinity of food products, for instance, determining the acidity in vinegar, citrus juice. The second type is redox titration. It used to determine the oxidizing or reducing agents in food, such as measuring the vitamin C content. And the third type of titration is a complexometric titration. It used to analyze metal ions in food, such as calcium and magnesium dairy products. And the last type of titration is precipitation titration. It used to determine the concentration of certain ions that form precipitates, such as chloride in salts. There are several applications can be applied in food industry for types of acid-based titration. The first application is flavor consistency, which means many foods and drinks like soft drink, juices, and dairy products have specific acidity levels that affect their taste. Titration helps keep these flavor consistent. Next application is safety standards. Food safety standards often require measuring pH and acidity to prevent contamination and ensure safety. Titration helps manufacturers meet this standard. Next, we go to the examples of acid-based titration in food industry. For the first example is soft drinks and beverage. The objective is to measuring citric acid for consistent taste and preservation. And the next example is fruit juices. The objective is to checking acidity for quality control and shelf life. And the last example is vinegar productions. It used to measuring acetic acid for accurate labeling and taste. Next, we go to the acid-based titration types and their suitable indicator. For the strong acid and strong base, there's any indicator suitable for the strong acid and strong base. And for the strong acid and weak base, metal orange is the suitable indicator for the strong acid and weak base. And the weak acid and strong base, phenolphthalein will be the suitable indicator. And for the weak acid and weak base, there's no suitable indicator for these types of titrations.
Assalamualaikum and hi, my name is Nordina Akila and I'm here to present about the methodology to determine the citric acid in Sprite. So, of course, in order to determine the citric acid in Sprite, we need to undergo the titration process. But before that, we need to remove the fizz from the Sprite first. There is two methods to remove fizz from the Sprite. The first one is decarbonation by standing, where the Sprite will pour into a beaker and just let it stand for about 30 minutes. And the second one is gentle heating, where we'll pour the Sprite into a beaker and just warm it up slightly, but do not boil it for about a few minutes. Both of them have the same function, which is it will have CO2 gradually escape and the Sprite will become flat. But for the second method, which is gentle heating, it will have CO2 escape faster. Here is the material and the chemical for titration process. But before that, as you can see, there is standardized sodium hydroxide. So how can we get the standardized solution? Let me explain. So first, we need to weigh the calculated amount of sodium hydroxide using analytical balance and transfer it into the clean and dry volumetric flask. Next, a small amount of distilled water was added to dissolve the NaOH. Next, the dissolved NaOH solution was transferred into 250 ml volumetric flask. Next, rinse the volumetric flask several times with distilled water and fill up the volumetric flask until the calibration mark with distilled water. And invert the volumetric flask several times to make the solution homogeneous. Okay, the apparatus and also the chemicals are already complete now, so let's do the titration process. So the first one, rinse the burette with distilled water to make sure it is cleaned to the titrations. Then the burette was filled with NaOH and the initial volume of NaOH was recorded. Then pour exactly 10 ml of Sprite into 200 mm aluminum flask. Then 2 drops of phenolphthalein was added to the aluminum flask and swirled to mix the content. Next, NaOH in the burette was slowly added to the Sprite drink until a faint pink color is obtained. Then swirl the flask until pink color remains for at least 10 seconds. Lastly, the final volume of NaOH was recorded and all these steps repeated 2 to 3 times. So that is how we can determine the citric acid in the Sprite.
This is the example of result for determining citric acid in soft drink. Titrating the Sprite drink with phenolphthalein as indicated, change the clear solution to light pink solution. This change indicates the neutralization of citric acid in the Sprite drink by sodium hydroxide solution. All the data has been recorded in Table 1. Based on the Table 1, we know that volume of sodium hydroxide used in titration was 8.6 ml, 8.4 ml, and 8.7 ml. Based on the result, we need to form a balanced chemical equation for this experiment. After that, we need to calculate the average volume of sodium hydroxide used, which is 8.57 ml. The first step, we need to calculate the mole of sodium hydroxide, which equal to molarity of sodium hydroxide times by volume of sodium hydroxide. So the molarity is 0.1 times by 0.00857 liter. The final answer is 0.00857 mole of sodium hydroxide. Second step, we need to find the mole of citric acid. Based on chemical equation above, we found that 1 mole citric acid is equal to 3 mole of sodium hydroxide. So, mole of sodium hydroxide must divide by 3, so the mole of citric acid is 0.000286 mole. For the last step, we need to calculate the concentration of citric acid in Sprite drink. To find the concentration, we must divide moles of citric acid with average volume of Sprite drink, which is we have been calculated below, 0.01 liter. So the concentration of citric acid is 0.02856 molar in Sprite.
Hi, I am Shaza Shamimi binti Azur Nizam and I will be wrapping up our video presentation. So, in conclusion, we have successfully discussed the titration in the food industry through theoretical, methodology, and experiments result. The titration experiments conducted to measure the citric acid content in Sprite provided valuable insight into the beverage acidity levels. By using a standardized sodium hydroxide solution as the titrant and phenolphthalein as the indicator, we were able to accurately determine the concentration of citric acid present in the soft drink. The results obtained demonstrate that the citric acid content in Sprite is consistent with the expected levels, and this shows the effectiveness of titration as an analytical method that can be used to determine an unknown concentration in the food industry. Titration has several beneficial effects on the food industry, contributing to the overall quality, safety, and nutritional value of food products. Here are some key positive impacts. First, titration helps in maintaining the consistency of food products by ensuring that key components like acidity, sweetness, and preservatives are within the desired levels. Next, proper acidity levels determined through titration help in inhibiting the growth of harmful microorganisms, ensuring food safety. And lastly, accurate titration allows for precise use of ingredients and additives, minimizing waste and reducing production costs. Overall, titration is a vital and ethical tool in the food industry that supports quality assurance, safety, nutritional integrity, and cost-effective productive processes. We rely on the following resources and websites to successfully complete these studies related to titration. And that brings us to the end. That's all from our group members. We'd like to thank you for your time and attention. Thank you for watching.